ሰላም ወደ ማትስ አካዳሚ ቲዩብ ቤተሰቦች እንዲሁም ይህንን ቪዲዮ ለምታዩ በሙሉ እንደናችሁ እንደምን ከረማችሁ አፕላይድ ማቴማቲክስ 2 በተመለከተ ዩኒት 1 እና ዩኒት 3 ላይ ያሉትን ወርክሺት ከዚህ በፊት ሰርቼ ለቀቄላችኋለሁ ከዩኒት 1 ዘልዬ ዩኒት 3 የሰራውበት ምክንያት አንዳንድ ተመልካቾቼ ሚድ ኤግዛም ስለደረሰ እና ዩኒት 3 ቶሎ እንድሰራላቸው ከመፈለግ የተነሳ ነው ስለዚህ በዚህ ቪዲዮ እና በቀጣይ ተከታታይ ቀናት በዩኒት 2 ላይ ያለውን ወርክሺት እየሰራው የምለቅ ይሆናል አብራችሁ ቆዩ Okay, now let's see the first question. እስኪ የመጀመሪያውን ጥያቄ ነው suppose that the power series given here converges at x is equals to -4 and diverges whenever x is 6. Okay, ይሄ የተሰጠን power series at -4 converge ያደርጋል at 6 diverge ያደርጋል ተብሎ ተሰጥቷል so what can be said about the convergence or divergence of the following series okay እዚህ አንደኛው ጥያቄ ላይ አምስት የተለያዩ ሲሪሶች አሉ እነዚህ ሲሪሶች converge ወይም diverge የሚያደርጉበትን ኮንዲሽን አብረን እናያለን so for a part let's take the power series given the power series an I mean cn x the power of n starting from 0 up to infinity this is the power series and it's given that it converges this series converges at x is equals to -4 and diverges at x is equals to 6 okay so ይሄ ምን ማለት ነው the series cn times -4 the power of n as n starting from 0 up to infinity converge ያደርጋል ይያልን okay based on the given information at -4 converge የሚያደርግ ከሆነ the given power series at -4 converges and it diverges at -6 ይያልን ነው ማለት ነው right I mean at positive 6 diverge ያደርጋል ይያልን ነው okay so we can apply ratio test here on this series so ratio test apply ብናደርግ we will have the limit of the absolute value of cn plus 1 times -4 the power of n plus 1 over cn times -4 the power of n this should be less than 1 ማለት ነው at x is equals to -4 converge የሚያደርግ ከሆነ this has to be true okay and this limit should be greater than 1 because of the convergence and divergence that we have here so ይሄ ምን ይሆናል ማለት ነው this limit is equivalent to the limit of in the absolute value you can simplify the expression inside here so ምን ይሆናል ማለት ነው 4 times cn plus 1 over cn as n approaches to infinity this is less than 1 at the same time this limit should be the limit in the absolute value 6 times cn plus 1 over cn as n approaches to infinity greater than 1 ነው ማለታችን ነው so this directly implies the limit of the absolute value of cn plus 1 by cn as n approaches to infinity 4n አውጥተን both side ማካፈል ነው so we can divide it both side by 4 we can get this and is greater than 1 over 6 so let me put this in red box okay so and this one in blue box okay so now we can have a certain condition for the convergence and divergence of a series in a ውስጥ ያለው series converge የሚያደርገው ይሄ ኮንዲሽን ሲሟላ ነው the limit of the absolute value of the ratio of their coefficients as n approaches to infinity should be less than 1/4. If this is satisfied, the given series converges, and this series, the series in A, will be divergent whenever the limit of the ratio of their coefficient is greater than 1/6. Okay, so this is the condition. Okay, now let's see the B part. What the B part እንመጣለን. In B part we have a series n is starting from 0 up to infinity cn times 7 the power of n. ይሄ ሲሪስ መቼ ኮንቨርጅ ያደርጋል መቼ ዳይቨርጅ ያደርጋል የሚለውን ነገር እናያለን. But from A part we have that this series converges at x is equals to -4 whenever this condition is happening ብለናል. The limit of cn plus 1 over cn as n approaches to infinity should be less than 1/4 የሚል አይተናል. This is the condition for the convergence of the series in A. በዚህ ጊዜ ይሄ ኮንቨርጅ ያደርጋል ብለናል A ውስጥ. And the limit of cn plus 1 over cn as n approaches to infinity greater than 1/6. ይሄ ኮንዲሽን ደግሞ A ውስጥ ያለውን ሲሪስ ዳይቨርጅ እንዲያደርግ ያደርገዋል ብለናል. ሶ እነዚህን ፋክቶች ለጊዜው እናስቀምጥና ወደ B part እንሄዳለን. So to check the convergence or divergence of this series, we use ratio test. So use ratio test. So the limit of the absolute value of cn plus 1 times 7 the power of n plus 1 over cn times 7 the power of n as n approaches to infinity. This can be simplified to the limit of cn plus 1 times 7 over cn as n approaches to infinity ማለት ነው. Okay, this is exactly the same as 7 times the limit of cn plus 1 over cn as n approaches to infinity. Okay, እቺን ፓርት ለብቻ ስናያት this term is less than 1/4. Okay, በ7 ብናበዛው ምን ይሆናል ማለት ነው? This should be less than 7/4. Therefore the series n starting from 0 up to infinity cn 7 the power of n converges whenever this limit is less than 7/4. Okay. Similarly, the series diverges whenever the limit of cn plus 1 times 7 the power of n plus 1 over cn times 7 the power of n as n approaches to infinity is greater than 7/6. Okay, this is the condition for convergence of a series in B, and this is a condition for divergence of the series in B. Okay, B ውስጥ ያለው series converge የሚያደርግበትና diverge የሚያደርግበት condition በዚህ ሁኔታ ነው ማለት ነው. In C part we have a series n starting from 0 up to infinity cn times 3 the power of n. Okay, the problem in B and C are the same except 3 is replaced. 3 is replaced by 7. Okay, C ላይ 3 ነው ያለው, B ላይ 7 ነው ያለው. So what is the condition for the convergence of the series in C ለሚለው ነገር B ውስጥ ካለው 7ን በ3 replace ማድረግ ብቻ ነው. So this series converges. So the series in C converges for the case this is happening, and it diverges. So the series in C converges whenever the limit of this ratio is less than 3/4, and it diverges for the case the limit of this ratio is greater than 1/2. So this is the condition for the convergence and divergence of the series in C. Okay, so if you properly understood ABC, D እና in the same procedure ትከተላላችሁ, and you will search a certain limit having the ratio of the coefficients. Okay, እንደዛ ነው የምታደርጉት ማለት ነው። Suppose that the power series here Cn times x minus a the whole n has radius of convergence R1, and this power series dn times x minus a the whole n has a radius of convergence R2. What can you say about the radius of convergence of the given power series? Explain your reasoning. Okay, እነዚህ power seriesዎች ተሰጥተውናል፣ radius of convergence አቸውም ጭምር። Okay, so based on this information we will try to see the radius of convergence of each power series in A, in B, in C. A, B, C ውስጥ ያሉትን power seriesዎች radius of convergence አቸው ምን እንደሚመስል እናያለን። So let's go to the A part. ወደ A ስንሄድ we have a power series n starting from 0 up to infinity Cn times x minus a the power of n. የዚህ power series radius of convergence okay እንግዲህ ምን እያለን ነው? የዚህ power series radius of convergence R1 ነው እያለን ነው። So we know how to calculate the radius of convergence. Radius of convergence and calculate ለማድረግ ወይ ratio test ወይ root test እንጠቀማለን። So ይሄ R1 obtain የተደረገው እንደዚህ አይነት calculation follow አድርገን ነው። The limit of in the absolute value Cn plus 1 times x minus a the power of n plus 1 over Cn times x minus a the whole n. Okay, as n approaches to infinity ይሄንን evaluate ስናደርግ የምናገኘው radius of convergence ነው R1 ማለት. So this implies absolute value of x minus a is less than R1 ማለት ነው. Okay, this is the radius of convergence for the original power series that we have here. አሁን ወደ A ስንመጣ A ውስጥ ያለው power series it's a multiple of this, it's a multiple of the given power series በp የተባዛ ነው p times Cn x minus a the whole n ይሆናል ማለት ነው። ይሄ p ከዜሮ የተለየ ነው። So የዚህ power series radius of convergence ለማግኘት የምንጠቀመው calculation it's the limit of p times Cn plus 1 over p times Cn times x minus a the whole n ይሆናል ማለት ነው as n approaches to infinity. Okay, እዚህ ጋር ማየት ያለብን p በp ይጣፋል። ስለዚህ ከማጋ ተመሳሳይ ይሆናል ማለት ነው። እዚህ ጋር ካለው power series ጋር ተመሳሳይ ነው የሚሆነው ማለት ነው። So radius of convergence the same ነው የሚሆነው ማለት ነው። So x minus a should be less than R1. Okay, so ከዚህ ምን ኦብዘርቭ እናደርጋለን? የሆነ power series ቢኖረን ያ power series በሆነ non zero constant ቢባዛ radius of convergence አይቀየርም ማለት ነው። Therefore the radius of convergence of the power series in A is the same as R1. Okay, with the B ስንመጣ we have this power series. Okay, in B the power series is n starting from 0 to infinity Cn plus dn times x minus a the whole n. Okay, B ውስጥ ያለው power series ይሄ ነው። ይሄንን rewrite ስናደርገው we can get that the power series that we have will be the sum of two power series Cn times x minus a the whole n plus the summation n starting from 0 to infinity dn x minus a the whole n ይሆናል። Okay, ወደዚህ ስንመጣ this power series has radius of convergence r1 ተብለናል okay and the radius of convergence for this power series is r2 ተብለናል so we are going to determine the radius of convergence for the sum of these two power series እንግዲህ ይሄ power series converge እንዲያደርግ ካስፈለገ because it's the sum of two infinite series each terms should be small otherwise converge አያደርግም to be the sum of these two power series convergent each terms should be small so here ምን ይኖረናል ማለት ነው the radius of convergence okay so the radius of convergence of the power series in B should be the minimum of the two radius of convergence so we can generally say the radius of convergence of the new power series that we have here will be the minimum of the two either is r1 or r2 ከሁለት አንዱ ነው የሚሆነው ማለት ነው